Hello everybody. Today we have a webinar in English language, and also we have local guys from Lithuania, so laba diena. We also have Maris from Latvia, so labdien, and Hugo from Estonia, tere. So today we will talk about the monitoring solutions, and initially I just will make some introduce some info about our GeoNovus group. So, Christian, you are welcome here. So, if you can rotate the slides. So today we will.
I will have. Good morning,
Okay.
everybody. Yeah, this is the agenda for today. As said, we are starting with an introduction of GeoNovus, and then we dive into the monitoring topic for today. And yeah, this contains some general information, and then about total station monitoring, additional sensors, and accessories and software.
Yeah.
I think we will have a Q&A session at the end. Is that right?
Yes. At
Florian?
the end, we can have live Q&A session, but
Okay.
also during the session we have a Q&A button.
Hmm.
Everybody
Perfect.
can ask questions in English or in Lithuanian, Latvian, or in Estonian language. So we can translate if it's question for you, or we can answer directly in our local language if we are able to answer by ourselves. So we can try to do various ways. Actually, it is the first time we are doing a webinar kind of
Okay.
like this for
Mhm.
Baltics in English. So we'll see.
Okay. Perfect.
Is it works well or not? We will see after we
Okay.
get feedback from our listeners or viewers, participants. Okay, Christian,
Good.
if you can go forward, yeah, about GeoNovus. Yeah, a couple slides about our GeoNovus. So a year ago, Trimble has different companies which were responsible for the Trimble products distribution in Baltics. So Geosoft was distributing products for many years, almost 30 years probably. In Estonia, Geostar was doing that in Latvia, and then GeoNovus in Lithuania. So that was situation year ago. And if you move one slide forward, uh, now we have united our forces. Yeah. Okay. Thank you. I see you updated slides to nicer one. Now we have discussed and decided to unite our forces and to have one brand for Baltics. So now Trimble products are distributed under the GeoNovus brand in all three countries from December of 2004. Okay, and the next slide. And our main mission and role to distribute, support customers related to the Trimble products, and many customers already knows that the main products are GNSS receivers, total stations, classical optical, digital levels, various 3D scanning solutions like Trimble X9, which used on a tripod, also MX60, which we can put on the train. For example, Latvians railways are using that, or some mobile mapping solutions, which also used in Baltics. So various 3D scanning solutions. About the monitoring solutions, we will be talking today. The Christian will help with that. Photogrammetry solutions. Also, we have Trimble Business Center, Trimble US Master, some Pix4D products for that. Also, drones, various US solutions. And in all three countries, we have Trimble repair centers. If somebody needs for help to adjust, to fix, to solve various issues for all Trimble products. So in all three countries, we have free repair centers. And if there is a need, we have various products for rental and can do some projects together with our customers. So generally, from my side, that's it. We will have recording of our webinar, but also before Christian continuing about monitoring solution, maybe Maris and Hugo want to tell something in English or in local language.
Hello, everybody. Sorry, I made some sentences in Latvian language. Tātad, labdien visiem no Latvijas. Tātad, šodien mūsu webinārs būs latviešu valodā. Tas ir angļu valodā, atvainojos. Ja? Tātad, ja jums ir kaut kādi jautājumi, apakšā ir Q un A tāds podziņa, spiediet tur un rakstiet rakstiskā veidā. Ja? Saprotu, laiks ir diezgan saspiests, tā kā lūdzu kompakti. Ja? Un beigās būs dzīvā sesija jautājumu un atbildes. Ja? Paldies jums! Hugo, your voice.
My turn, okay. I will say in Estonian also. Tere kõigile, et kui on küsimusi Kristjanile, siis pange kohe chati inglise keeles, et pärast siis on küsimuste-vastuste voor ja kui on eestikeelselt, siis võib ka kohe chati panna, et siis ma siis vastan nii, kuidas me oskame. Nii et kena webinari kuulamist kõigile.
Okay, thank you. Just to introduce myself a bit, as you can see, my name is Christian Breuer. I'm based in Germany. I'm with Trimble since 2002, and most of the time I was taking care of the monitoring products. I'm currently the so-called monitoring sales manager for us here in Europe, and some other areas as well. So you see, I already went to the next slide. What is monitoring? And during all these years, I'm working now with the monitoring portfolio. I many times get some kind of concerns from many people. That monitoring is so difficult. And when you look at these pictures here, you could think, it's such a difficult setup, and especially when you look at the right photo here, this is a bad example of a monitoring installation. It's weird with all these cables and solar panels, and that actually makes people afraid of starting with monitoring. But what I would like to show today is that it's quite easy. It is quite easy to get started with monitoring, and I also think that you can reduce it to the simple term you see here. When we talk about monitoring, I don't talk about monitoring my neighbor from my window. Of course, monitoring is a word that is used in many different ways. And when we are talking about monitoring, of course, it is about geodetic monitoring, monitoring of movement, monitoring of structural behavior. And when you look at this line here, you can actually say, hey, I'm just repeating observations to the same targets, to the same structure. I'm observing a structure for movement, and that is pretty simple. And most of you, I mean, most surveyors and other engineering offices, you're doing it today. You are using your survey equipment, to take observations to prisms. You do level runs once a week, once a day, to observe whether there is settlement. So it's nothing really new to you. And I'm pretty sure that most of the people in the call have been doing some monitoring or deformation measurements in the past. And typically, what you do is you create the results of each observation, and then you put it, for example, in an Excel spreadsheet. And then you show that Excel spreadsheet, or maybe you add some graphs in there, and then you provide it to your clients. The good thing is that Trimble has a lot of tools, little ones and more complex ones, that allow you to make this whole workflow a lot easier. And that is what we are talking about. There's special field software tools that you can use. There's special office software that you can use to streamline your workflows. And again, what I want to say is getting started with monitoring is very easy. Yeah? While we are talking about standard survey equipment, I want to start with showing how to improve your workflows using a total station. Yeah. But before so, we want to look also into specific applications where monitoring is being used today. Yeah. And I don't want to do a deep dive into that, just to highlight where this technology can be applied. And in the end, of course, the idea is to provide you with new opportunities where you can provide your professional services to others. Yeah? And when it comes to monitoring, yeah, of course, immediately we are talking about monitoring of structures, yeah, and in this case here, transportation infrastructure that can be rails, that can be roads, that can be canals. Yeah, you might have a canal or a dam where there are ship locks that you need to monitor. Yeah, that's done frequently by our clients in other regions. Yeah, rail is a very hot topic. Yeah, because there are many infrastructure projects going on in Europe. Yeah, there is since many years of the plan to connect the major cities in Europe with new railway lines, and then mostly these railway lines, these new ones, are being constructed in corridors that already exist, yeah, in parallel to existing railway lines, yeah, and then of course monitoring of the existing infrastructure is required. Another thing is buildings. Yeah, whenever you have historic buildings, for example, and there is construction going on, and you want to make sure that the historic buildings or other buildings adjacent to construction sites are safe. Yeah, then in many cases it's already today compulsory to set up a monitoring system. Yeah? Because in the end, when something happens and the construction is affecting buildings next to the construction, yeah, um, you need to prove is the damage, for example, related to the construction, or was it there before? Yeah, and what is the extent of the movement? And of course, it is a safety equipment in case there is movement. Then you can react. You can immediately say, okay, stop working at that side, yeah, because now something is happening to the structures around it. Another big topic, maybe less important in the Baltic region, is mining. There are a lot of open pit mines in the world that are using the Trimble technology to monitor their pits, the pit walls, but also structures which are adjacent to pits, and this is basically dams, yeah, because a lot of the mines they are producing a lot of wastewater and they store it in dams, and they need to monitor these dams, of course. But also other dams are being monitored. Yeah, at least a dam of a certain size, yeah, in a that is a potential hazard to the people living next to it, yeah, has to be monitored. Yeah? I'm pretty sure that most of the dams in the world, they have already some basic monitoring systems. Yeah, you do level runs on the dam crest once a year, twice a year, probably twice a year. Yeah, when the water level is high or when the water level is low. So a summer observation and a winter observation. But also there are other sensors in the dam itself, yeah, that are being used to monitor, and we can help to modernize, of course, these existing installation, because the dams that we are looking at, yeah, most of the dams in Europe, they are pretty old. Yeah, they have some basic monitoring systems, but with the technology of today, they can easily be automated and extended. And of course, there are also natural hazards, yeah, that can be monitored by our technology. For example, landslides or in mountainous areas. Less a topic again in the Baltics, yeah. But I just want to mention, in the end, it is not a question of what is moving. Yeah, we can use that technology to monitor basically any structure that is subject to movement, whether it is caused by a natural behavior or or by construction or anything else. Are there any questions so far that have been dropped into the chat? Can you verify? Okay, just an introduction.
We don't have any questions.
Okay, then I will move forward with the presentation. You have to excuse me a bit because I got I got a cold some days ago, so my voice is a bit rough. All right, using our survey equipment for monitoring applications. Yeah, and as I said, I'm pretty sure that a lot of people have already been doing this. Yeah, and that is why I would start with an example, which is very very basic. Yeah, but nevertheless, it is important. Yeah, let's start with manual data collection, and let's assume that you have your total station. Yeah, and you have already a field controller of some sort. Yeah? So this can be this TSC7 or any other controller running the Trimble Access survey software. Yeah, and when you look at this example here, that's a construction pit. I like the picture because it's a deep one, and I've never seen the approach of this before. But that is nothing that is very special. We see this with a lot of metro construction projects in the world. Yeah, so you have a deep excavation in the city center. Yeah, and you need to monitor the excavation pit itself, but also the buildings around. So, what can you do by using the technology that you already have in your hands today? Yeah, what you would do is you would drive to the site. Yeah, set up your instrument. Yeah, and once it is set up, you observe the targets. Yeah, once you've observed the targets, yeah, you go back to the office. Yeah, to process the data or use the results. Yeah, create that famous Excel sheet that I mentioned initially. Yeah, and once that Excel sheet is done, you maybe make it up a little bit by adding some graphs in Excel. Excel has these capabilities, and once you have done so, you provide these results to your client. Yeah? And after some time, you go back to the site and repeat the same story again and again. So that is a standard workflow. And if you just need to do this once a week, yeah, or once every second week, that is a proper workflow. Yeah, you don't need to have an automated system for every single site. Yeah, but what you can do is you can still improve the workflow on site with little tools. And one little tool is the so-called Trimble Access monitoring application. Yeah, it's a little add-on, yeah, that you can put on your controller. It's an add-on to the Trimble Access survey software. Yeah, and that little tool improves the workflow on site already a lot. Yeah. Of course, you still need to drive to the site and set up the instrument. Yeah, that will always be the case. Yeah, but then the instrument observes all targets automatically. Yeah, you don't need to do this manually. Once you have observed all the targets in the field directly, you can create the report on it. Yeah? So you can output the values, and you can output graphs for the movement over the observed periods. Yeah? And then you can immediately in the field provide these reports to your client in a PDF, in an Excel sheet, or even in a Word document if you want to do so. Yeah. And then, of course, yeah, you can go easily and go to the next site, do your next job. Yeah. All right. That is a pretty straightforward workflow, yeah, and it reduces the amount of time on site. If you have multiple jobs, or if this is a long-term project, or if you want to bring in observations from other instruments, yeah, you can also use a little add-on which is made for the Trimble Business Center software. I think most or many of you at least are already using Trimble Business Center for your standard survey work. Yeah, and there's also a little tool available, a little add-on, a module available for TBC that allows you handling monitoring data in a very easy way. So how does this change the workflow on site? Well, of course, you still need to drive to the site, set up the instrument, then the instrument observes all the targets. But then, you simply sync the data with your office by using the tools that are available via Trimble Connect, for example. You sync the data with the office, and then you can go to the next site. Do your next job, because there is your colleague in the office. He can use your data now. And he can use other Trimble survey data and calculate the results. And he can create the reports easily. By using the Trimble Business Center monitoring module. And he can provide also the results to your client. So this is less time on site, less time for you in the office. And finally, there is another way. If you think, okay, monitoring, there are a lot of monitoring jobs I can do, and I wanna provide some more sophisticated analysis and alarming. You can also go for the so-called Trimble 4D control software. That is a dedicated monitoring software which can do a lot of tasks, and I will highlight some a little bit later. But how does that now change the workflow on site? You still, of course, need to go to the site and set up the instrument, observe the targets. You sync the data with the office, but then, the T4D software, Trimble 4D control software, manages the data. It will process the data automatically. It will automatically create the reports, and it will provide the results to your client. So T4D, I will show you in a minute, can create reports automatically according to a schedule that you set up, but also it provides a web user interface that you can share with your clients. So if you want your client to look at the data by himself, you can set up access for your client, and you don't even need to send the reports, because every time when the client wants to see an updated result, he can go and check that result by himself. Okay, now we have been looking at manual data collection, and I don't think that is a big problem for anyone here on the call. But let's assume you now see that there is movement, and you need to increase the observation frequency. Then it makes sense to automate the system. And the good thing is, all the data that you have already collected manually, which is in T4D, in Trimble 4D control, you can still use it. That, of course, but by exchanging one component here in that setup, you can automate that observation very easily, and that is being done by this little box here in the middle. That's the Trimble monitoring controller, which is called SetTop M1, and this little box replaces your field controller. And what it does first, it operates the instrument autonomously. So you can use that device to set up a schedule for your observations. And according to the schedule you set up, you will the instrument will observe the targets. The observations will be transferred directly to the Trimble 4D control monitoring software. And if there is an interruption in the internet connection, for example, because this works via internet, the data will be stored locally, and once the connection is back, the Trimble 4D control software will pick the data, and will reprocess it subsequently, so that you don't have any gaps in your monitoring data. It provides also power to the instrument. So you just need one power supply, either mains or car battery, which is charged by solar, or whatever power supply you have available. So there's just one cable that goes from that box here to the total station, and it also checks, of course, the total station, whether it is operating properly or not, and it will give you then the information that everything is all right, or it will send you alarm in case there is something happening. As I said, it is using internet connection to provide the data. Typically, you just put in a SIM card, and then there is a remote proxy service connected to it. You just need the username and password, and the data will be, the connection will be routed to your device. So you do not need a static or public IP address. You just need to use a specific customized URL, username and password, and then you can connect to that device. As I said, data is not lost in case internet connection drops. The data will be buffered on the device itself and reprocessed once the connection is back. And you don't to configure it. You can do this remotely, from your office, or you can connect to that device via a local Wi-Fi connection, and configure it to do the observations. In case you have done manual observations with that Trimble Access app before, you can simply transfer all the reference observations to that device, and it will continue where you stopped with the manual observations. Total stations, I don't think I need to talk about this too much. Typically, for most of the applications, that instrument in the middle is the best choice. The Trimble S7 comes with integrated camera, and it's available in different accuracies: 1 second, 2 second, 3 second, 5 second. And important, it comes with the so-called fine log sensor. The fine log sensor is important for monitoring because you need to make sure that the instrument, of course, is picking the right prism. And it is doing the automated target recognition very precisely. And for that purpose, in monitoring, we only use instruments with that fine log sensor. The S7 comes with it, but sometimes maybe you require some additional features. You require, for example, a higher accuracy. You need a half-second instrument, or you require an EDM, which provides higher accuracy. Or you maybe you need to monitor over long distances. Then you could go for the Trimble S9 because it comes with these optional features here. Higher accuracy, I mentioned. Long range fine log is an additional tracker that is available for that unit, which allows you to lock onto passive targets up to, 2.5 kilometers or so. So when you are monitoring a dam, for example, from a far distance, or a bridge or so, where the standard tracker would not be sufficient, then you can go for that long range option of the S9. The SX12 is also available for manual monitoring. It has, of course, an excellent camera system, much better than the S7 and S9. And you can also use this with the Trimble Access monitoring app, and you can also use the images. And you bring these images into the 4D control software, and you can actually visually monitor the change on site by using the photos that you took with the SX12. All right. There is also an example here that Maris wants to talk about. That's an installation in Latvia. So please go ahead and explain that project.
Okay, we have one installation in Latvia, but I explain this is a critical infrastructure object. I cannot tell you where it is, but you see a small picture here at the left side. This is this object. And it's equipped with S9 high precision total station, setup M1, and it's observe every hour 4 times each of targets. It means 6 reference points and 16 observation points. And data transmission and real-time accuracy, it's around 1 millimeter. And it works now more than 2 years on the field. Yeah, this is the first installation and quite successfully works. Okay, thank you for this.
All right. Yeah, the client is very happy with that installation, and because of that, he's now considering to add additional sensors, additional devices to monitor additional parts of that structure. And when we talk about additional monitoring sensors, yeah, we can immediately think of the sensors that we are familiar with. And when we are talking about additional survey sensors, of course, we first look at GNSS. And GNSS, of course, brings a lot of advantages to a monitoring site, because with GNSS it is possible to monitor, of course, at very high frequency. Yeah, Mars just said in that monitoring project in Latvia, we are observing the targets every 15 minutes. Yeah, with GNSS, as you can imagine, we can create much higher frequencies. Yeah, we can have for example, a result every second. Yeah, if we have a more dynamic application, yeah, where we expect sudden movement, yeah, then of course GNSS using GNSS technology is the right choice here. Of course, the drawback is that you cannot observe so many targets with a single setup. Yeah, you need multiple receivers. Yeah, and in order to observe multiple points, yeah, you need then the equivalent amount of receivers. Of course, there is one model that we have here that is a dual board. Let's see on the right hand side. If you have 2 points that are pretty close to each other, let's say 10, 15, 20 meters, yeah, or 50 meters, yeah, you can use that dual board receiver, which is also supported by the Trimble monitoring software, and that allows you, of course, then to monitor 2 points instead at a very high frequency. The good thing with the Trimble monitoring solution is you can use it. You can process the data in many different ways, and you can do so in parallel. Yeah? So what you can do is you can process the data, of course, on the receiver itself, yeah, by providing real-time corrections from a physical base station, or also from a worldwide network of reference stations that Trimble is operating, and that is the so-called RTX data stream. So in that case, you do not need to set up your own base station. Yeah, that is specifically interesting when you have an area where you cannot be sure that you can find stable reference points. So then using that worldwide reference station network with RTX corrections is a good option. But at the same time, you can stream the raw data from the receivers to the Trimble 4D control software, and you can have the software process the data for you. So you can use multiple base stations. You can process an entire network of receivers in the software, and you can do so in real time. So the software has an integrated real-time engine, an RTK engine, but in parallel, you can also process the data in longer intervals. So there's an automatic post-processing engine integrated, yeah, that allows you to take data over longer periods of time, 1 hour, 1 day, a week, and process very high precision results by using these post-processing technologies. Okay, these are just 2 examples of GNSS receivers we support. There are others, but typically we use one of these models here. That you can put the receiver basically in a cabinet, save it from the environment, yeah, and just have the antenna outside. Theoretically, you also could use other integrated receivers, of course, for GNSS processing. Then,
Christian, before going forward, maybe you see in Q&A chat one question, and you could answer live to that.
Okay. On a metal. Okay, so there's a question in the chat here. I saw a total station on a metal plate in Mario's pictures. Does it also have position changes due to temperature, sun, and other factors? Yes, this can happen, of course. Yeah, if you are not sure whether your total station is actually at a stable position, yeah, the software, of course, allows you to use the total station and in a resection. Yeah, that means you can monitor the position of your total station, and you can see whether there is an influence, yeah, in the position of the total station. Generally, when we are doing monitoring by using total stations, we always use, of course, temperature correction and pressure correction. Yeah, so the setup M1 always comes with an external temperature sensor that allows you to measure the air temperature, and the instruments, all of the instruments that I showed, have an internal barometer, air pressure. So it measures the air pressure, and these are used to calculate corrections for the EDM, of course. Yeah. The software has additional tools to do atmospheric corrections by using reference targets. Yeah, but if you are interested in this technology or how it is working, then we can take this offline. But yes, we can monitor the position and also other factors that are influencing the measurement itself, but also monitor the impact of the temperature, of course. Yeah. If you are not, if you need a more sophisticated weather station, if you need to monitor additional parameters like wind speed, wind direction, and so on, you can also integrate a full-blown weather station to the monitoring software and use this data to optimize your observations. Yeah, I hope that answers the question.
Small comment. Customer made special housing for this temperature measurement for this object. This example from Latvia. Yeah.
Yeah. So of course you need to monitor the air temperature. Yeah, and the air temperature needs to be measured in a certain spot. Yeah, when you look at a official weather station, then the air temperature is always measured 2 meters above ground. Yeah, and you need to put a little housing around the sensor, as Maris said, where there is a ventilation. Yeah, in there. Yeah, but these are some basics about how to measure temperature properly. Third-party sensors. Third-party sensors can also be integrated into the software, and this is typically where most of the surveyors get a little bit nervous because they say, oh, what are these sensors? I don't have experience with it. Yeah, but the good thing is that compared to a total station, yeah, or compared to processing GNSS data, what we all can do, what we all know about, yeah, these third-party sensors are very easy to use because they do not require any big processing. Yeah, they just provide results. Yeah, and the results could be, for example, a tilt sensor. Yeah, so that it gives you the inclination of the structure or the change in inclination. Yeah, and there are many different sensors. Yeah, that provide air pressure. Again, that like a weather station that I just mentioned. So air pressure, humidity, rainfall, wind speed, wind direction. Yeah. or vibration itself. Yeah, if there is construction going on and the machinery is inducing vibration to the adjacent buildings, that can be observed. And there are sensors that you can put in the ground, yeah, to measure the groundwater level or the pressure on the groundwater. Crack meters, strain gauges, and so on. But all these sensors, yeah, they are very simple. They typically provide 1 or 2 or 3 values, yeah, and you don't need to do any processing. Yeah, you just need to record them and bring them in. There are some different technologies that are being used for these sensors. Basically, one, as you can see here, is analog. Yeah, analog means these sensors provide a change in voltage or in resistance or in electric current. Yeah? So they don't measure the crack width, yeah, in millimeters. Yeah, they measure a change in voltage. Yeah, because there is some electrical component that is changing, and then this sensor that come with a formula. Yeah? So when you buy one, yeah, there is a little data sheet coming with it, and it says, okay, one change in voltage equals 1 millimeter in displacement. Yeah, and that formula, yeah, you simply enter, yeah, and off you go, and you have your change in voltage. But the good thing is it is very, very simple to integrate these sensors into our solution. Yeah, this is an example from one of our partners, load sensing here. Yeah, so load sensing is providing, as you can see here, a fully integrated digital wireless tilt sensor. So how does it work? Yeah, it is battery powered. Yeah, you install it. Yeah, and then you take your mobile phone, connect to the sensor, and what you tell the sensor is, hey, please send your data to a central gateway. And you type in the serial number of that gateway, 12345, username and password, and it's done. So that sensor then provides tilt and temperature to the central gateway. And it does so by using LoRa technology. LoRa is an abbreviation for long range, low power communication. Yeah, and this allows you to send the data wirelessly to the gateway over distances up to 15 kilometers, depending on the site, of course. Yeah. And then on the T4D side here, that's representing T4D, the globe on the right. Yeah, you do basically the same. Yeah, you add a gateway connection by entering the serial number of the gateway, username and password. And once you have done so, T4D will populate a site and with a list of all the sensors that are sending data to that gateway. You pick the sensors that you want to have in your project, yeah, and you are done. So this is an example for a very highly integrated sensor. Yeah, it is very simple, but sometimes you want to connect other sensors. So a crack gauge here. Yeah, that's. Can you see my mouse cursor, by the way? Yeah. So that's
Yes,
a crack gauge here that you mount on a over a crack, yeah, and will automatically monitor the change in the crack width. Yeah. This one here is a so-called piezometer. Yeah. This you put typically in you either put it in the lake. Yeah. In the lake if they have an artificial dam. Yeah, and you put it in the lake to measure the change in water level, or you drill a hole, yeah, put it in a pipe, and you measure the level of the groundwater by measuring the change in pressure. Yeah? And the same here, you connect it to a battery-powered logger, yeah, by cable. Yeah, you use your phone to configure the logger by basically doing the same, telling it, hey, please send the data to the gateway with the ID 12345, and you are done. The only difference now in the gateway is that you need to also enter the formula to convert the data from the change in frequency, from the change in voltage, yeah, to pressure or to the difference in level. in water level. Yeah, but that is all coming with a sensor. Yeah, all the manufacturers, they have will give you a calibration certificate. Yeah, with the formula, you enter the values for the standard formulas, and off you go. And T4D receives pressure or a change in water level. Yeah. And the same applies to all the other sensors that they're typically used. One comment here on that one here, that's also, let's say, a very basic GNSS sensor. That's also provided by load sensing here. That is using RTK technology to process the data, but it is also battery powered. Yeah, that means it will not continuously monitor the position. Yeah? The way it works is you will set up a schedule. For example, you will set it up to wake up every hour, do a measurement, receive corrections from a base, process a position once an hour, and then that position will be sent to the gateway, and then the receiver goes to sleep. Yeah? So you can use it for long-term slow movement observation, but not for real-time observations where you expect sudden movement. And finally, there are also other sensors available. And this one here, that the Syscom sensor, is a vibration sensor. Vibration can be measured by measuring the change in velocity or acceleration of that location. That is also used frequently when you want to observe the ambient vibration close to a construction site, or maybe if you observing a dam, yeah, because when a dam is also subject to a vibration due to the seismic or microseismic activity. Yeah, you can imagine when you have a dam, the water, the load of the water is not only putting pressure on the dam, but also on the rock around the lake. Yeah. So and that pressure, that load basically is causing microseismic activities. Yeah. And that is something you also want to observe. Yeah. Because you don't want to have a sudden change in that activity, which is then indicating maybe that rocks are falling into the water and can cause trouble to the dam itself. Okay. Here's another example from the Baltics. There is also that story is also available on our partners on World Sensing's website. Maris, do you wanna add some comments on that one?
Yeah. Okay, this is one example how to use these sensors in reality. As you see, this is Gediminas Tower and some landslides at this object. Yeah. Okay. What I like to explain a little bit more about these sensors. This is the first necessary to very detailed to study what you really need, in which what accuracy requested. Some sensors give you very good relative accuracy, but sometimes for these geotechnical sensors exists some how it is moving of 0 point and need a long time to recognize which it's moving of this 0 point, in which scale and what affected temperature, pressure, or some sunshine or climatical periods. This is necessary to study. Not possible to find these static movements, small movements at the first year, for example. Yeah, need the time a little bit more. Yeah.
Okay, that was about additional sensors, and as I said in the beginning, you don't need to be afraid of these sensors. Yeah, they're so simple, and the integration into a monitoring system is really very easy. Okay. Accessories, yeah. We talked about housing, we talked about protection for the instrument and so on. Of course, we have a whole bunch of accessories which you can use for setting up a monitoring system. Yeah. Starting with prisms, yeah, we have special monitoring prisms for different applications. On the left side, the black one is our standard one that you can that is typically used if you have very long shots where you need high precision, especially on backsides. You can go for the one which is seen here. Yeah, a very high accuracy, very small beam deviation reflex. If you want to co-locate prisms on top of each other, or if you want to put a GNSS antenna on top of a prism to monitor the position of the prism with GNSS, that is a solution here. If you have to monitor a road surface or other sections where you want to be sure that it's that the prism is protected, you can use one of these. Or if you have bolts, already existing survey bolts, for example, in a tunnel, you can use the one on the right-hand side to screw it on existing survey bolts. I also mentioned protection. Yeah, so we have a housing, we have mounts for the instrument, as you can see, wall mounts and pillar mounts, and also cabinets to protect, for example, the electronics, the receiver, or the M1, or both. And one more thing to mention here is the thing on the left-hand side. That's a self-leveling tri-brake, and that is actually used quite frequently. I see there is a hand coming up. Is there a question?
No, my small comments.
Okay.
Okay, about accessories and so on. It is possible to buy standard accessories, but it's possible also to build locally.
Right.
Yeah, if you have a request, please give us. We have experience to build some unique adapters. For example, we built for laser scanning special lift for train wagon. Yeah, which lift the scanner up to 4 meters high. Yeah, this is all possible. Only need exactly data.
Yeah, sometimes it is required to have some customized equipment. Yeah. Just before I go to the questions, let me quickly finish with this one here. That self-leveling tri-brake is meant to be used for total stations, which are being installed then in unstable area, of course. Yeah. I mentioned that we can use the total station in a resection setup, yeah, so that it can compensate for movement. But if it is a really, really unstable area, that might not work, because you can imagine that the electronics within the total station, the electronic compensator, has a specific working range, and when the instrument would be tilted too much that the compensator is getting out of range, then it will the software will stop operating the instrument, because you don't want uncompensated observations. But the good thing is you can connect that little yellow tri-brake there also to the setup M1. As the setup M1, the monitoring controller is monitoring the instrument, it will recognize when the compensator is going to be out of range. And then it will turn on that self-leveling tri-brake. It will level the instrument again. And then it will continue to operate with the compensator in range. On the right-hand side, that's another picture of a weather station. I mentioned that one before. Okay, before I give a little overview on T4D, I will just look at the questions. When can we expect the addition of load sensing to T4D? load sensing sensors can be already integrated. That's what I just said, I think. If you okay, then what sensors are better to use for monitoring building verticality? Would those be inclinometers or tilt sensors? For a building, depending, of course, on the size of a building, tilt sensors, of course, are the better choice because you are independent when you are choosing a location. Yeah, the software in T4D, you can virtually connect these sensors. Yeah, so that you can associate a specific segment of the building with one tilt sensor, and you can create a virtual chain of tilt sensors, and then you can monitor the horizontal movement as well as the inclination, because it's typically not a linear thing. Yeah? So the upper parts will incline more, of course, than the lower parts. That's due to physics. When you say inclinometers or tilt, I mean a tilt and gives you inclination. A tilt sensor gives you inclination. When you think about an in-place inclinometer, which is a physical chain of tilt sensors, these are typically used when you have a borehole. Yeah, so when you have let's say a borehole of 15 meters, yeah, and then you put a chain of tilt sensors and you lower it into the borehole, and then you can see the horizontal movement within that borehole over time. And you are referring to the vibration sensors. I don't know. We at the moment we only use the Syscom vibration sensors. I cannot tell you when the load sensing vibration will be added. I have no information on that one. And finally, what about 3D scan data from Trimble X9? Can it be used for construction site progress tracking or monitoring? That data can only be used in Trimble Business Center monitoring or in Trimble Business Center at the moment. Yes, it's on the list for also for analysis and deformation monitoring in T4D.
Yeah.
Okay, while we are talking about
Christian, I have a little bit about that question about point clouds. So yes, it can be done not automatically, but manually in Trimble Business Center, also in Trimble RealWorks. So if you need to compare cloud to cloud, surface to cloud, a 3D model like BIM model to point cloud, so we can do that in Trimble Business Center and Trimble RealWorks. So you can contact us, and personally I can make a demonstration how to do that comparison to different surfaces, point clouds, models, and whatever data you have. Yeah.
And if you are using, for example, an SX12 instrument, you even can do so in the Trimble Access Monitoring app directly in the field.
Correct. Correct.
Okay. Finally, I wanna take I'm a bit slow today, so we are running a bit over time. But I just want to give you some ideas of how Trimble 4D Control is working and what additional benefit it gives to you. As you can see here, that's the center. That's the core piece of every monitoring or automated monitoring installation that we have. A lot of different tools to analyze the data and log events and alarms and so on. Of course, it will alarm you immediately, by email, by SMS or so, if there is something happening on site. I mentioned already the web interface. Yes, if you want it, it is a fully automated system that takes care of all the data that is coming in. When you log onto the web UI of Trimble 4D Control, it will look similar to this one here. Yeah, you see there is a lot of functionality behind, but it's very easy to use in the end. Yeah. So there is a section about sensors, yeah, a section about all the stuff that you can bring in, yeah, meaning how to visualize the sensor data in all these different ways by using webcams, images, maps. You can visualize it on 3D models. You can create automated reports. Of course, you have a section that allows you to do account management because you can actually grant access to others, yeah, but you want to make sure that these people only see what you want them to see. So you can create very specific account and access levels to this. Naturally, you would expect a map view, of course, yeah. So you can by default use open street maps, and if you have an account for Google, a key for Google or Bing or so, you can also use Bing and Google Maps, of course. You can also create your own geo-referenced maps. Yeah, if you and load them into the software and use your geo-referenced pictures as a backdrop image. You can even bring in your own web map server. Yeah, many authorities, they have their own maps, cadastral maps or maps of many different sorts. Yeah, where you can access, and then you can integrate that map server also here. You can also simply take a picture. A picture with your mobile phone that shows the site, and then you move the sensors at the location so that others can see the position in the real world, and you can overlay here, of course, the readings of the sensors and graphing and so on. You can create your own dashboard, yeah, by putting different graphs together on one side and make this dashboard accessible to others without creating an account. You can publish it to the outside world in front of basically the web UI, in front of the login. Yeah, and visualizing the data also is a personal thing. Some people prefer to use it, to see the data in this way or that way. Yeah, this is an example of a bar chart where you can then monitor the different height changes at points that you have been leveling, for example. Vibration data can be visualized and analyzed in a specific vibration event section. You can use webcams, live webcams, and overlay it with the sensor position. As I mentioned, you can also bring in 3D models, and then you can rotate that 3D model and see the sensor position and the movement vectors, for example. Yeah, and which is for 90% of the users, the most important stuff is you can set up automated reporting. Yeah, so that every morning, every Monday morning, 9 o'clock, for example, yeah, you get an email, an automated email with a PDF file, yeah, that gives you an overview of what happened during the course of the week. Yeah, gives you, for example, a chart that shows the behavior of the sensors, the behavior of the structure over the last week, and you don't even need to touch it if you want to. And worth mentioning here is one thing for Trimble 4D control. You can also have a dedicated rail module. Why is that? Number one, there are a lot of railway projects going on. There is a lot of construction going on existing railways, and many of our installations are being used to monitor rail tracks. The total station or a tilt sensor, yeah, they will provide you displacement or tilt or inclination of the rails. But most of the survey authorities, they are not interested in 3D displacement of a rail. Yeah, they wanna see the results relative to the actual railway geometry. Yeah, and this T4D rail module allows you to upload a file which contains the railway geometry, and then when you observe the targets on the rails, or if you bring in a tilt sensor and place it on the rail, it will automatically calculate the values which are required by the rail authorities. Meaning, it will take the rail geometry, and will calculate all these values here, that you can see. The cant or the change in cant, which is called the twist here, horizontal displacement of the main axis or of the left or the right rail or both. And even when you cannot measure to the rail itself when you're using a prism on the sleepers, but the software will automatically calculate all these values for you, and you can create the appropriate reports automatically in the software, so that the rail authorities can understand how the movement is affecting the geometry of the rail tracks. Having said that, I think that was one of my last slides. That is actually the one just summarizing the capabilities of T4D. So if you want to, it can do everything automatically. If you want to work with it, want to bring in manual data, no problem at all. The big benefit is that you can provide the data to your clients immediately, and you are always up to date. Having that said, thanks a lot. Thanks a lot for listening. I run a little bit over time, but I hope you still stay here for some more questions and answers. Thank you.
Thank you, Christian, for showing us and presenting Trimble monitoring solutions, the hardware and software, which fits well. And we can wait for a couple minutes to see, do we have any questions? So far, I don't see any other additional, but we can wait for a couple of seconds. Maybe Maris or Hugo have some comments or information.
I think maybe Christian can comment also about the number of sensors what we can connect to T4D software. So that is probably people needs to know or understand also.
Well, there is actually no limit. If you look at geotechnical sensors, it is very easy to handle the data because they just provide a very small data set. So you don't need a huge server to calculate the data. Basically, you take the data and store it, and if you want to visualize it, the database will be analyzed. Processing power is required when you have a very big network of GNSS receivers. Let's say if you would operate 50 GNSS receivers, and you would do real-time processing and post-processing or multiple real-time processing setups in parallel, then you would need a server with let's say higher specs. But we can provide the specs that would be needed for such a setup. But total station data is also very small compared to GNSS data. GNSS data, as I said, can come in up to 1 Hertz or even more. If you want to have a dynamic analysis of the data. With the total station, you typically have an observation once an hour or once every 15 minutes, 30 minutes. That is not a huge amount of data, and that can be easily processed with the standard PC. Typically, we advise the people to use a cloud machine. Go to Microsoft Azure or Amazon Web Services. They provide virtual machines for a good value. And the positive thing is that you do not then need to install it in your own company network. You can, no problem. Yeah, but if you are working for a bigger construction company and wanna do a software or a special software installation within the network, you need to be good friends with the IT people. Yeah, because they are always skeptical. Yeah, they don't accept whatever. Yeah, as let's say non-standard software, and T4D is a standard software when it comes to, yes, it can be installed on any Windows machine, but it's not like Microsoft Word. Yeah, so you need to have set up a web interface, and if you want to share that web interface externally, some people already get nervous. Yeah. So it's easier to use a virtual machine, and the good thing with a virtual machine is, if you have a system which is growing, yeah, if you add sensors over time, yeah, and really would require some more processing power, yeah, you can just scale it up, and easily provide more processing capacity to that virtual machine.
If it is possible, small comments from my side. In the past, was a huge problem to deliver data from the sensor to the main computer. Now, with wireless technologies, this is very simple at the moment, really. Yeah, and let's not remember about cabling and so on. Only one small thing still it's actual. This is power for the sensors. Yeah, for the small sensors, for geotechnical sensors, battery lives. It's approximately 5 up to maybe 10 years for one battery. Yeah, without replacement. And solar batteries, it's also help a lot. It means that not necessary to provide long cables, and cables itself, it's a problem with sometimes with some animals, some broken cables, and so on, so on. Now this is very easy, really. But for some purposes, this is still a problem. This is not changed for GNSS antennas necessary to provide clear sky. This is still active, and no noise, and no any multipass for GNSS signal, and this is still. Yeah, and the same for optical total station. This is sometimes limitation if it is temperature different at the total station location and target location. If it is different temperatures, yeah, this is maybe some problems. Yeah,
But then
I think
principles which we cannot change it.
yeah, I think we ran out of time for this webinar. So maybe Christian, you can answer to last few questions, and yeah,
okay.
probably we should
Okay.
finalize.
Currently, the T4D database is stored on each user's system. Is there a plan to introduce a cloud service from Trimble? Yes, there is a plan to do so. And the second question, do you have any projects about monitoring system which are installed on bridges? Yes, we also do bridge monitoring. Yes, bridges on so that the correct setup for a bridge depends, of course, on the type of bridge and what you want to monitor. Some bridges are made of steel, yeah. Some are concrete, some are made of bricks, yeah. So yes, we do a lot of bridge monitoring, but when you wanna start a setup there, you need to determine, of course, what are you monitoring? Is it movement? Is it vibration? Is it inclination? We have huge bridges where we have a combination of, again, crack sensors and tilt sensors and GNSS on the pillars, yeah, high up on bridges that are going over long distances, yeah, crossing even the sea. Yeah, we have a nice setup. a big setup on the bridge, which is connecting, for example, Bahrain and Saudi Arabia. This is a bridge stretch of many kilometers, yeah, with a little island in the middle. Yeah, but the entire section is being monitored by different technologies. Yeah, total stations at some parts, GNSS on other parts, and geotechnical sensors from below. So yes, we also do bridges. Yeah.
So, thank you so much, Christian, for presentation. And I would encourage our local guys, customers, users to contact us in case you have any various questions. So we would gladly answer to those. So yeah, thank you, and bye.
Thank you.
Bye.